Okay, perfect. Thanks for taking care of this. And welcome all to the SIG Autoscaling meeting on the 19th of May 2025. Okay, let's look at the agenda. I see that we have Adrian here. So first item of business, does the VPA need to support downgrades by a single version cleanly like Kubernetes does?
I know I've been away, but does it make sense to have Ray as part of this conversation?
Probably. I'm assuming he's not here.
He doesn't seem to be on the call. I mean, I'm happy to
Yeah,
wait. It's not an urgent
we
thing. It's
can.
just more of a philosophical discussion of like what shouldn't be doing, and
Okay,
then let's write it down. But we can wait.
we can postpone. Jack?
Cool.
When we do have the conversation, just to add a wrinkle, there are complexities in, if we're comparing to Kubernetes, there are certain combinations of configurations that are not downgradable, and those are supposed to always go into release notes, but you'll see in release notes things like if you enable this alpha feature flag with this alpha feature flag in 127, when you go to 128, you can't go back to 127. It's too early in the morning for me to have a concrete example, but something like that is possible. So there are always exceptions.
Yeah, and I think again, without going too deep, VPA probably might have similar situations, but at the same time, it's a significantly smaller and less complicated project. So maybe we can have I don't know, just we got to figure out what makes sense for the project and then write it down and move forward.
Yeah, that makes sense. Okay, let's move on. I don't think we have Karthik here. I've been following up with them on Slack, and they made some update to the cap, so this is all in progress. So the next HPA PR to discuss.
Yeah, hi. I read the PR about the HPA with some users having a problem that when the when the pods are scaling, because the scale is taking too much in a case of time, then the pod is unready. Okay, when a new pod is scaled, it's unready due to its load due to its load. So I read the PR, which is something dirty I wrote, which helped the HPA scale the pods not only when a pods are ready, but as a fallback to its current replica. I mean, I know I don't really explain myself very good, but I attached the issue in the PR itself, and I wanted first of all people to have their own opinion and maybe take a look and maybe have a discussion. It's currently just me and Adrian are making a progress in the HPA, so we want to have more people, make some contribution as well. And I've talked to Magic about it, and he said that in his opinion, the best way to do it is to have it, like in the HPA CRD, to have another field for when the HPA doesn't detect any ready pods, to have a fallback to current replica in the scaling algorithm. So just, if some people can share their opinion and how they see this thing going on, I'd be glad to help out. And I know that Jack has approved some of my PRs, so thank you, Jack. And I'm really looking to your opinion as well. And that's all.
Please, I know that HPA is not in a good place right now, reviewer and approver wise. So please reach out if the review gets stuck and can't progress. Okay.
Yeah. I'll reach you.
This expertise, but I'll definitely try to facilitate and find somebody to approve.
Okay, thank you.
Hey, Omer, I don't fully understand. I'm sorry, I was gonna just quickly respond. I don't fully understand the scenario, but it does sound like that would be a cap. So you might want to, if you feel strongly about evolving the HPA CR, I think that would definitely reach the cap requirement threshold. So you can maybe start the cap on that or define what that would look like. Go ahead,
I don't know for this one specifically, but I would also like to remind people that we have the AEP process, which is a bit more lightweight. And so if the proposal doesn't really touch anything outside of SIG Autoscaling, if we don't need to align with some other SIG, then it's probably best to at least start with the internal autoscaling enhancement proposal. Because a cap is pretty heavyweight for most like iterative changes within autoscaling. But
This
it might
is
touch those things where it's important for sure.
This is HPA though, so this is in KK. So I feel like a cap is probably needed.
I see. Okay.
Yeah, I was
that
going to
makes
say,
sense.
I mean, I think an AEP might be, yeah, it's just a code-based thing. It's definitely, I think, under SIG Autoscaling's
if it's in
responsibility, but
KK
because it's in the Kubernetes repository. Yeah.
Yeah, if it's in KK, sorry, I forgot. If it's in KK and if it requires a field change, then definitely, yeah, a cap would be warranted. Okay, disregard then.
Yeah.
Any
Also,
other
if I
comment?
have 1 more minute of your time, I also want to raise this cap about this issue. Just to get more people involved, what's going on. Currently, the HPA scales your target ref by selecting the labels on the pods, and not by it just taking the labels and just scales your pods with the selected labels. And so if you have a job, let's say, and a deployment with the same labels, so and the job is having a CPU throttling or something like that, then your pods in the deployment will scale also. So I want to make a cap about this. Me and Andrea are both working on this to have a, maybe take a look at on reference or something like that, just to fill you in, and I'll start working on this cap this weekend. So just make sure we're all in action.
Thanks for the heads up. Very good to see some work on HPA being done. So thank you for that.
Thank you.
Okay, if we're done with that topic, next one is from me, just added. So I met with the Carpenter folks last week, and we would really want to bring them into the fold here, and for them to be able to join the SIG Autoscaling meeting on a regular basis. And the current time is just too early for most of North Americans to join us. I know there are some exceptions here, and thank you for that. So they are fine with starting an hour later than we do right now. So this is also just a heads up. I want to follow up with the other SIG leads and find out what sort of constraints we have within the lead group, and then I'll follow up with a wider proposal to the community. Yes, Nico?
I just want to note that like an hour later is going to collide with the brand new node lifecycle working group that just started.
Yeah, see, this is exactly what we need to figure out. Maybe a different day will be needed. Like, this is not a mandate or anything. I'm just floating the topic. The problem is that we want to make the time more US friendly, and we have to figure out how to get there. And the minimum threshold for Carpenter is 8 a.m. their time.
Right. So we can't make it too late for Europeans as well, right? So
yeah, so we have pretty much, we have the bounds. We need to find a good day, and maybe if there is no such date, maybe we'll just have to set up some less regular meeting on a different day, an hour. Like, there are things that we can explore. I'm just floating that, like, if anybody has any hard guarantees or knows about any similar conflicts, like the working group, just please let me know. Or just wait for my proposal and complain then. Yeah.
I hate to suggest it, but this call does have VPA, HPA, cluster autoscaler, and
yes,
maybe if we have to, then splitting it some way might make sense.
I definitely would want to do that. Thanks for reminding me. I would like to do that as part of that. So right now, the like we're doing node autoscaling and the others together, but the sets of expertise here are very different. Like I'm most knowledgeable about node autoscaling. We have some folks on the call who are mostly knowledgeable about the workload side of things. So I think at minimum we would want to split the meetings somehow and have some less regular meeting that brings both together so that we still have a space to talk about cross-functional issues. So yeah, this will be a part of that, and it's definitely something to figure out still. I hope to work on this in the coming weeks.
Thanks.
So that's it from me. Do we have any other topics?
Hi, I have another topic I'd like to discuss. I'm trying to have a cluster autoscaler manage up to around 2,000 nodes. And I looked through some documentation. Seems like, typical recommendation is below 1,000. And I'm looking for ways of like how to make the cluster autoscaler a bit more performant at that range. Wondering if others have explored this.
Oh yeah, I think it should be able to handle more than 1,000 out of the box. Like that's just my intuition. We have definitely explored a lot of performance improvements internally in GK in our fork, and we've also done more like some improvements to the core logic as part of that. And I think they're probably not captured in any of the recommendations that you might have bumped into. So I would definitely recommend that you just try your setup out first, grab some sort of benchmark. If things seem too slow, then we can focus on what's actually taking time and what's being slow.
Yeah.
I think we have a lot of experience debugging cluster to scale performance issues.
Yes, so I've done a few load tests. The numbers I've gotten were, so specifically scale down can be very slow. That can be very bad in terms of just like burning money. So I think
have you tried messing with the parallelism settings and the scale down delay? Like there is a collection of flags that can be tweaked to make it faster. We can follow up on that on Slack if you want.
Yeah, I can. Actually, I don't have Slack access yet. But yeah, if you could add me, that'd be great. I can send you.
I don't think we're able to add you.
Slack
There's
is self-service. You should be able to do it yourself.
It's a Kubernetes wide thing. You should be able to find instructions.
Okay. Okay. But yeah. So I've tried tweaking a few of the like scale down flags, parallelism flags. What I keep getting stuck on is actually the cluster autoscaler figuring out which nodes to are able to be deleted. That was my biggest. Is especially tricky when I'm trying to scale down like 1,000 nodes and scale up 1,000 different nodes. That has somewhat problematic. So yeah, I can.
Okay. If you have I think you're like further along than I initially thought. So if you have a comprehensive like sort of analysis like that, like what you tried, what is being slow, if you could gather all of that and just open an issue in our repo, and just ping it to me somehow on Slack, I think we can just follow up on there. Seems like a straightforward thing to debug and at least get you an answer on like where the slowdown is.
Okay.
Jack, sorry, because I know I've been talking over you. Sorry.
No, it's yeah. I also like briefly looked over some of the code where like I see we're doing decision making for node can be turned off. So yeah, I'll do all of that. Maybe I'll also try to like I don't know, maybe try to make a pull request or something. Try things. So yeah, okay. I'll follow up with you. Thank you.
Jack, you had a hand, right? Sorry for that.
Yeah, I just wanted to. So, if we have documentation in the project that suggests you can't run cluster autoscaler over 1,000 nodes, I'd love to have a chance to update that. In my experience, dating back several years, there wasn't a single cluster running at like 1 to 5,000 that wasn't running some sort of autoscaler. Because being able to managing nodes at that scale manually is super challenging. So it's way harder to do it manually. So I think there might be some legacy documentation. I'm not sort of to Kuba's points, it is more complex to find the right set of configurations. For example, the loop interval needs to be tuned so that it can actually finish in time before the next one, and it obviously is going to take larger to finish because you have to create simulations based on larger data structures. One best practice would be to ensure that maybe you have a dedicated node pool that's not being auto-scaled, that runs the cluster autoscaler runtime, let's say like on a 16 core machine, and set an appropriate taint so that only the cluster autoscaler runtime can be there, and give it access to more or less the entire machine or VM. Because all the state machine is in memory. So it's not something that you can horizontally scale across multiple cluster autoscaler pods.
Yeah, that's with Carpenter as well.
Oh, sorry.
It's the
for
same
sure.
with
But
Carpenter.
the point is just, give the runtime, let's say 32 gigs of memory and lots of cores, so that it can generate those simulations super quick. And if there are any operational optimizations that are still to be had, just give it more overhead so you can absorb that. I think it's a small cost to pay at that scale for being able to, take advantage of economies of scale on the order of hundreds or thousands of nodes. Like, having one really beefy node is going to still save you tons of money.
Yeah, when I was testing, like bumping up. So for a while we were kind of resource constrained there, and then bumping up memory and CPU helped a ton.
It helps up to a point. There is a cutoff where if you're running into there are just some, like, taking away everything else, there's just some pitfalls that you have to avoid to just break scalability. Like, not for scale down, but for scale up, we have interpod affinity, which just slows down CA to a crawl. And there are just like little things that can be there in the setup, that there are like hidden scalability dimensions. Like, I think CA scales way more, like it has more difficulty scaling with multiple node groups than it has with multiple nodes in the same group. Things like that.
Right.
There is a lot, and probably best to look at it comprehensively on the issue.
Yeah. That makes sense. Like, for a reference, I have around it's to like 20 to 40 node pools. And then biggest challenge is when there's like two node pools that are scaling up or scaling down simultaneously. Also, one thing I mentioned, so like the typical thing I have running is that I have one pod per node. There's some daemon sets running, but like the pod has anti-affinity, which I've read so very problematic, right?
That is the pitfall I was just mentioning. Interpod affinity is extremely costly because it breaks many of the optimizations we have in CA. That it sort of breaks assumptions.
Is there a way to get around that though? Like, can I do something to still have one pod per node? But
oh yeah. I mean, you can size the pods to the node size. That's like if you know the shapes up front.
Yeah.
You can size it.
Overcomes.
You can. A very involved solution is to have some custom resource that you consume on the node, just like a pod slot. There are various ways of doing this, and also I think you can isolate the complexity if you if you have such. Does that apply to all of your pods or only a subset?
So I mean, like effectively
if it's a subset, then we could sort of isolate it from the rest of CA somehow. If it just applies to all of your pods, I can definitely say that in GKE we have like the one pod per node setup is extremely popular, especially recently, and we strongly recommend against using interpod affinity to achieve it.
Is it?
So we have ways around it that we can talk about for sure.
Okay, you said pod slots?
Yeah, like for one, like if you're okay with firing up your own device plugin, you can just expose a custom resource on the nodes and then have them consumed by the pod, so that only like the easiest way to achieve 1 pod per node is to just size the pods to the node size, right? So you have some resources on the node, you take 80% of them by the pod, that is pretty much guaranteed nothing else will come there, right? Or you taint the node group, and then you guarantee that it's 1 pod per node. So the custom resource is sort of a way of doing that without knowing the resources up front. Sort
Okay.
of a way to reserve, but it is pretty involved, and there are probably easier ways.
Okay. Okay. Yeah. No, I like that idea. I'll try that. You said I can taint or just do the sizing. Okay, that makes sense.
That would be my first guess. Like if you have a fixed node shape that you're working with, and so just bump the resources so that no more than 1 pod can fit on it. That's the easiest solution.
Okay. Okay. Sounds good. And do you think it's worth, like, one thing I saw is that can be very inefficient is like for the cluster autoscaler to determine when to scale down a node, and it does like all this digging in, but I was just thinking like it would be really nice to have like I could label the node or something that it's like just delete this. Instead of trying to iterate through all of the pods and then say, oh, okay, these nodes are removable.
But you would want to do that manually?
Well, I know exactly when I want to delete a node, yeah.
Yeah, like Carpenter has this, CA doesn't have this feature. Should be an easy addition. But I don't know if, like, one way to optimize this, depending on the workload, is to make sure that your pods finish and die when they actually are done. Like if you know that, okay, I can delete this node because all of the pods are no longer working there. If they were to finish, CA has a much easier time deleting nodes that are empty. So empty meaning only daemon sets are there. Because then there are no simulations. Like the way, the reason why it's slow is CA never wants to scale down a node where if it causes the pods that were there to not be able to reschedule and become pending. If a node doesn't have any pods running on it that would need to be rescheduled, it goes into a completely separate logic for scaling down empty nodes, and this is significantly faster.
Oh, okay.
So if you can get your setup to do that, especially in a 1 pod per node, it's just one workload to make work with it, should speed it up.
Okay, I saw there were flags like ignore daemon set. Would that do that? Or
no, these are different. These are either for whether we're counting daemon sets when calculating utilization, which you probably don't want to do, and the other one is whether we are sending them an eviction request when we are deleting a node, which is not applicable to performance.
Okay. Okay. But then how would I? Oh, would I have to like drain the node or something?
You would have to either make change the application to actually like finish when it dies, and then, but that will have to be a job, right? A pod doesn't work like that. Sorry, like a deployment doesn't work like that.
Yeah. How do I?
Or you could have some system that comes in and deletes this pod, and then CA can work on the node easier.
I see.
You have one more thing. You mentioned you're running 20 to 40 node pools. I would definitely. That's really, really difficult to run a single cluster autoscaler configuration that optimizes generally across that many node pools, unless they're totally sort of homogeneous in terms of the way they behave. But I would imagine that various node pools are dedicated to certain applications that might have different requirements. So you might benefit by having more than one cluster autoscaler runtime on your cluster. So some are dedicated to a particular set of node pools that have a particular kind of configuration. Like it might be that certain node pools are able, you can basically reap those really quickly. So you can have really aggressive scale down configuration for those, but they're less appropriate for others. So it sounds like it might be more maintenance, but it's just becomes more complex because cluster autoscaler has so many different configuration dimensions that you're sort of like trying to find a kind of median that is best for all.
It matters
Yeah,
a
go
lot
ahead.
for scale up. I don't think so much for scale down. Then the actual node groups don't really matter. Only the amount of nodes the pod can be rescheduled to. And even if you configure multiple cluster autoscalers, they will all consider all nodes. They consider all nodes, even those that aren't autoscaled, for scale down when rescheduling pods in the simulation, because this is what will happen in reality. So I would try the other things first, but then, and in GKU we definitely have way more node pools, but we also have optimizations for that I'm hoping will relatively soon bring to the core CA. Like for example, the sharding and starvation of one group by another. Like we have a component in our internal fork that does some sort of least recently used on the node groups, and then starvation is much less of an issue. And
it is a little bit better than the purely open source one.
Yeah. But still, there are many things we can try before we get to a point where we need to shard, I think.
Okay, cool. Yeah, I've been so like I work at a company where we deploy software to multiple different cloud providers for our customers, and so the customers that want the scale are on AWS. But yeah, that's interesting. Okay, cool. I think I have a few things to try. I'll try to get on the Slack and but appreciate all the advice. Thank you guys.
Okay, and we're over time, so let's finish. Thank you. See you next week.
Thanks, Cuba.